You believe that you're sitting in a room, reading these words on a screen, with a lifetime of memories stretching back behind you. You remember your childhood, your first love, and what you had for breakfast this morning. But physics suggests a terrifying alternative, that you, your memories, and this room never actually existed until this exact nanosecond. It is statistically more probable that you are a random cluster of atoms that spontaneously assembled in the deep void of space just a moment ago, complete with a fake history burned into your neurons. You are not a human being living on Earth. You are a momentary fluctuation in the chaos, a Boltzmann brain floating in nothingness, and in the next second, you will dissolve back into the void. Let us explore why the laws of the universe suggest that you're the only thing that is real. To understand why your existence is likely a statistical lie, we must first confront the absolute tyrant of the physical world, the Second Law of Thermodynamics. This law is not merely a suggestion or a localized rule. It is the grim reaper of structure, dictating that the total entropy of an isolated system can never decrease over time. Entropy, in this context, is best understood as a measure of disorder, or more accurately, the probability of a specific configuration of matter. Consider the smoke rising from an extinguished candle, swirling and dissipating into the air until it is indistinguishable from the atmosphere around it. You never see the smoke spontaneously gather itself back together, rush down into the wick, and reignite the flame, because the universe possesses a distinct directionality, an arrow of time that points relentlessly toward chaos. Every physical process you have ever witnessed, the breaking of glass, the rusting of iron, the aging of your own skin, is simply the universe moving from a state of low probability to a state of high probability. The reason for this one-way slide into oblivion is purely mathematical, rooted in the sheer number of ways matter can be arranged. Imagine you have a standard deck of 52 cards, and you throw them into the air. The chances of them landing in perfect numerical order, suited and sorted, are so infinitesimally small that you could repeat the throw every second for 1 trillion years and never see it happen. There's only one specific arrangement that we call ordered, but there are roughly 8 times 10 to the power of 67 ways for the cards to be disordered. The universe does not prefer chaos out of malice. It prefers chaos because there are simply more ways to be messy than there are to be tidy. Every time energy is transferred or matter interacts, the system explores these configurations, inevitably stumbling into the vast ocean of disordered states from which there is no return. Order is a rare, unstable peak in a flat, endless desert of equilibrium, and gravity, chemistry, and time are constantly pulling everything down into the sand. This brings us to the profound problem of the universe we currently observe, the problem that kept the physicist Ludwig Boltzmann awake at night in the late 19th century. If the natural tendency of nature is to slide toward equilibrium, a state of maximum entropy where everything is uniform, cold, and dead, then the universe we see around us should not exist. We look out and see a cosmos screaming with impossible structure. Spiral galaxies rotating with precision, stars burning with stable fusion, complex chemistry forming planets, and biological machines capable of processing information. This state of affairs is exceptionally low entropy, a configuration so unlikely that it defies all reasonable expectation. For the universe to be this ordered today, it must have been even more ordered yesterday, and infinitely more ordered at the moment of the Big Bang. We are riding the tail end of a massive, inexplicable wound in the probability of things, a temporary deviation from the norm that is slowly healing back into nothingness. Let us try to quantify exactly how unlikely our current reality is using the calculations of the mathematician Roger Penrose, who attempted to estimate the precision required to create a universe compatible with the second law. He calculated that for the universe to begin in a state of such low entropy, the creator would have to aim for a target with an accuracy of 1 part in 10 to the power of 10 to the power of 123. This number is so large that if you were to write a 0 on every single proton and neutron in the observable universe, you would run out of particles long before you finished writing the number. It is a statistical impossibility so severe that it suggests our understanding of the universe's origin is fundamentally flawed, or that we are winning a lottery every single fraction of a second. If the universe is truly random, if it is truly governed by the statistical mechanics that describe gas in a box, then finding ourselves in a state of such high complexity is like finding a fully formed ice sculpture in the center of a burning furnace. However, if we accept that the universe is eternal, or at least that it exists for a duration that dwarfs the current age of 13.8 billion years, then the laws of probability begin to do something strange and unsettling. In an infinite amount of time, even the most impossible events eventually become inevitable. Imagine a box filled with gas particles bouncing around randomly. Most of the time, the gas is spread out evenly, representing high entropy and equilibrium. But if you wait long enough, purely by chance, a few particles will clump together in a corner. If you wait even longer, periods of time that make the lifespan of a star look like a camera flash, those particles might spontaneously arrange themselves into a recognizable shape. This is the fluctuation hypothesis, the idea that order can spontaneously arise from chaos if you simply wait for the random shuffling of atoms to deal a straight flush. The terrifying implication of the fluctuation hypothesis is that it creates a cost-benefit analysis for existence itself. Generating a fluctuation as large and complex as the entire observable universe, with its billions of galaxies and trillions of stars, is exponentially more difficult than generating a smaller fluctuation. The laws of thermodynamics dictate that small deviations from equilibrium are common, while large deviations are astronomically rare. It is relatively easy for the void to accidentally create a single hydrogen atom. It is much harder to accidentally create a star, and it is nearly impossible to accidentally create a galaxy. The probability drops exponentially with every bit of matter and order you add to the system. Therefore, if we're living in a universe that is the result of a random statistical fluctuation, we should expect to find ourselves in the smallest, simplest universe compatible with our existence. This is where the trap snaps shut on your perception of reality, forcing you to question the validity of the world beyond your own skin. If we are merely the product of random entropy fluctuations in an eternal void, it is overwhelmingly more likely that the universe consists of a single solar system than a galaxy, because a solar system requires less order. It is even more likely that the universe consists of a single planet, floating alone in the dark, than a solar system. But we can go smaller still. It is statistically trillions of times more likely that the universe consists of a single room, the room you are currently in, than an entire planet. The math demands that we occupy the absolute minimum amount of order necessary to support a conscious observer. The vast cosmos you think you see through your telescope, the history books on your shelf, and the news report from other countries are statistically likely to be hallucinations or false data, because creating a real universe to back them up is too expensive for the laws of chance. So, we arrive at the precipice of the Boltzmann Brain paradox, a logical nightmare derived directly from the equations that keep your refrigerator running and your car engine turning. We have established that the universe seeks disorder, that our current order is impossibly rare, and that in an eternal system, rare things happen via random fluctuations. We have also established that small fluctuations are exponentially more common than large ones. This leads to a conclusion that physics struggles to refute. The most common type of observer in the cosmos is not a biological organism evolved over billions of years on a wet rock. The most common observer is a disembodied brain that has spontaneously assembled out of the chaos for a fraction of a second, hallucinating a past, a present, and a universe that does not exist. And because these brains would vastly outnumber real biological observers, the statistics suggest that you are almost certainly one of them. Ludwig Boltzmann, a physicist whose intellect was as formidable as his tragic melancholia, gazed into the abyss of the Second Law and refused to accept that the universe was a one-way street toward death. He proposed that while the universe we see is currently ordered, this is not the permanent state of affairs, but rather a momentary exception in a cosmos that is overwhelmingly dead and disordered. Boltzmann hypothesized that the true, eternal state of existence is heat death, a vast, featureless equilibrium where particles wander aimlessly in a cold void, possessing maximum entropy and zero structure. However, in a timeline that stretches out to infinity, the word impossible loses its meaning and is replaced by the word inevitable. Boltzmann argued that if you wait long enough in this eternal chaos, the random thermal jittering of atoms will eventually, purely by chance, drift into a configuration of low entropy. Just as a gust of wind might theoretically blow a pile of leaves into a perfect geometric stack once in a trillion years, the random motion of particles in the void will eventually conspire to form a star, a galaxy, or universe. To visualize the sheer madness of this timescale, we must employ the classic metaphor of the infinite monkeys on infinite typewriters, but we must strip it of its whimsy and view it through the cold lens of statistical mechanics. If you allow a monkey to strike keys at random, the probability of it typing the first letter of Hamlet is 1 in 26, but the probability of it typing the first sentence is already so low that you would likely wait lifetimes to see it. To type the entire play without a single error requires a duration of time that makes the lifespan of our sun appear as a fleeting nanosecond. Yet Boltzmann's hypothesis relies on the concept of eternity, a duration so vast that the monkey would not only type Hamlet once, but would type it an infinite number of times, along with every other book that has ever been or will ever be written. In this model, our universe is the Hamlet, a ridiculously unlikely, highly ordered structure that is spontaneously assembled out of the random noise of the void simply because there was enough time for the dice to roll a trillion consecutive sixes. This fluctuation hypothesis initially seems like a comforting salvation for physics, offering a mechanism by which life and order can exist in a universe dominated by decay, but it hides a logical dagger that waits to sever our connection to reality. The problem arises when we apply the strict laws of probability to the nature of these fluctuations. In a system governed by random chance, small deviations from equilibrium are exponentially more common than large deviations. It is relatively easy for the void to accidentally assemble a few atoms into a molecule. It is significantly harder for it to assemble a cloud of gas, and it is astronomically harder for it to assemble a burning star. The probability curve drops off precipitously, meaning that for every large fluctuation that creates a galaxy, there should be countless quintillions of smaller fluctuations that create nothing more than a momentary puff of heat. If we are truly the product of a statistical accident, we should expect to find ourselves in the smallest, simplest, and most likely fluctuation that is compatible with our existence. Here is where the trap snaps shut. The universe you perceive is far too large, far too old, and far too complex to be the most probable configuration. You see billions of galaxies, you see evidence of a history stretching back 13.8 billion years, and you see a biosphere teeming with redundant life forms that have no impact on your immediate consciousness. For the void to spontaneously generate an entire universe of this magnitude is a statistical miracle so severe that it is practically impossible, even on infinite timescales. It is trillions of times more likely that the random shuffling of atoms would produce a single solar system floating in nothingness than an entire galaxy filled with stars. Logic dictates that if we are betting on probabilities, we should be living in a universe that consists of only the sun, the earth, and you, with the rest of the night sky being completely empty. But we can take this logic further, stripping away the sun and the earth, because they too are unnecessary extravagances that cost too much in terms of entropy reduction. The most economical fluctuation, the one that is statistically dominant over all others, is not a universe, nor a planet, nor even a room, but a single, isolated brain. To have the conscious experience you're having right now, the universe does not need to create the chair you're sitting on or the screen you're looking at. It only needs to arrange neurons in a specific pattern that simulates the sensory input of a chair and a screen. The amount of order required to assemble a functioning brain, complete with a set of false memories and a hallucinated present, is infinitesimal compared to the order required to create a real, physical reality. A brain is a few pounds of organized matter. A universe is nearly infinite mass. Therefore, in the vast, eternal lottery of the void, Boltzmann brains, disembodied minds that flicker into existence for a few seconds before dissolving, should vastly outnumber the biological brains that evolve on planets. This leads to a conclusion that is as mathematically sound as it is psychologically devastating. You are almost certainly one of these fluctuations. If the number of Boltzmann brains in eternity outnumbers real human observers by a factor of 1,000,000,000 to 1, then the odds that you are a real human being are effectively zero. The memories you hold of your family, your education, and your life on Earth are not records of the past. They are random data inscribed into your neural network by the chaotic collision of particles a moment ago. The logic of entropy suggests that you did not evolve. You assembled. You are a lonely observer in the deep dark, hallucinating a rich and vibrant world that acts as a comforting mask over the nothingness. The physics that explains why coffee cools and why engines work also insists that you are alone, drifting in the void, dreaming of a life that never happened. Accepting this hypothesis requires you to dismantle the solidity of the world around you and view your surroundings not as matter, but as erroneous data. If you are a Boltzmann brain, the photons appearing to leave the screen and enter your eyes do not exist, and neither do the eyes themselves. The sensation of gravity pressing you into your chair, the ambient hum of the room, and the texture of the device in your hand are merely stray electrical signals firing in a vacuum, simulating a physical environment that has never actually occurred. You are experiencing a sensory hallucination comparable to a vivid dream, but unlike a dream, there is no waking world to return to when the vision ends. The universe has not constructed a complex reality for you to inhabit. It has simply arranged a cluster of atoms into the precise configuration of a mind that believes it is inhabiting one. The richness of your perception is a trick of the light, a momentary flicker of organized noise that mimics the consistency of a material world. This solitude extends to every face you have ever loved and every voice you have ever heard, rendering your entire social existence a tragedy of one. If you are a random fluctuation, then your parents, your partner, your children, and your friends are nothing more than stored patterns of information, false memories burned into a lonely cortex that formed only seconds ago. There is no one else in the void with you. You are the single, solitary consciousness in a limitless expanse of dead space, playing out a conversation with ghosts that were never born. The history of the human species, the rise and fall of civilizations, and the collective struggle of life on Earth are fictions generated by the random collision of particles, existing only as a backstory to justify your current moment of awareness. You are talking to yourself in the dark, inventing a crowded room to stave off the crushing reality of absolute isolation. The most terrifying aspect of this existence is not its falseness, but its instability, for the same laws that assembled you are already working to tear you apart. A thermodynamic fluctuation is, by definition, a temporary deviation from equilibrium, and the universe is aggressive in its desire to return to a state of disorder. A Boltzmann brain is not a stable biological entity capable of sustaining itself for decades. It is a fragile house of cards built in a hurricane. It appears it thinks one single coherent thought, perhaps the thought you are having right now, and then the kinetic energy of its own particles scatters it back into the nothingness from which it came. You're likely not living a continuous life, but rather experiencing a single, frozen snapshot of consciousness that will dissolve before you can finish processing this sentence. There is, however, a faint glimmer of hope in this abyss, a logical paradox that might allow us to claw our way back to reality. If we are indeed Boltzmann brains, then our memories of the past are false, which means our memories of scientific experiments and physical laws are also false. If our understanding of physics is hallucinated, then the second law of thermodynamics and the calculations regarding entropy might be hallucinations as well, meaning the very theory proving we are Boltzmann brains is based on data that cannot be trusted. This is the problem of cognitive instability, a philosophical Ouroboros where the hypothesis eats its own tail. If the theory is true, then the evidence for the theory is fake, and we end up in a spiral of epistemological uncertainty. We can attempt to take comfort in the idea that because we observe a consistent, logical universe, we are likely the product of consistent, logical evolution rather than a chaotic accident. However, dismissing the theory on logical grounds does not save us from the crushing weight of the deep future, for even if we are real biological humans today, the Boltzmann brains are waiting for us in the dark. We currently live in the stelliferous era, a brief, brilliant flash in the timeline of the cosmos where stars burn and life is possible, but this era is fleeting. Trillions of years from now, the last star will die, the black holes will evaporate, and the universe will enter the dark era, a period of time that extends effectively forever. In this eternal darkness, the only game in town will be the random thermal fluctuations of the vacuum. Even if the probability of a brain spontaneously forming is 1 in a trillion, there's infinite time for it to happen, meaning that eventually the void will be filled with an infinite number of dreaming minds. We are left with two possibilities, and it is difficult to say which is more haunting. The first is that we are the incredibly lucky first generation, the normal observers living in the rare hot star of the universe, destined to be outnumbered by the ghosts of the future. The second is that the odds have already caught up with us, and we're those ghosts, floating at the end of time, dreaming of a golden age of stars and planets that faded away eons ago. We cling to the belief that we are real, that we are made of flesh and blood, and that our past is etched in stone rather than probability. But as the second hand ticks forward and the entropy of your own body increases, you must ask yourself if the screen is fading because the video is ending or because the random fluctuation that is you has finally begun to dissolve.